Hi everyone. Today we will talk about the OSPF protocol. This is the most important routing protocol in the networking. What is OSPF? OSPF is a protocol that helps to have an easy and dynamic configuration and communication between the routers. So today in our lab we will build a simple network where we will explain this. Okay, let's start to build our network, simple network. We will go to the network devices here, and our network will be done with three routers. Let's select this one. Okay, and we will have another one and a third one. Okay. Then let's connect. We will have two end devices, okay, as two PCs. So we will select the PC, okay, from this section end devices, and we will go to the first one option, and we will go to the PC, okay, to select it here, okay. We will click it and click here. Okay. And we will in our lab we will use as a device between intermediate device between the router and the PC as a router. Okay, I'm sorry, a switch. Okay, we will connect it. So we will go to network devices and switches. Let's select okay, this one. We will use only, of course, two devices because the switch is the device that is connected with the end devices inside a LAN. Okay, and the same will be here in this part. So what is our LAN? The LAN is a device that has the same IP configuration mask, we can say. So here, this is our LAN. So this is the first network. Okay, this is another LAN. Okay, this is a second network. And when we go over the router, so we have a WAN. Okay, a wide area network. So this is a WAN. Okay, and this is another WAN. Okay, and all the devices um, has the form of WAN. Okay, uh, let's connect the cables. Okay, connect the devices together. We will use the automatic connection option here. This helps to connect all the devices together without selecting each port. I mean that, for example, if I get this cover crossover cable and I will click on the PC, it asks me which port I need to connect it with. I will select fast Ethernet 0 and it tells me what device I want to connect with. Of course, in this case will be the switch, and I have to select, for example, fast Ethernet 0 1. Okay, and the same with other devices. Okay, for example, here if I say from the router fast Ethernet 0 and I connect it with fast Ethernet 0.2. Okay, instead of doing this manually, I can use this option here. This helps to connect do the same connection but automatically without selecting the port. So I will only click on the router and go to click on the other router and connect it manually. Okay, and I will do the same for automatically. I'm sorry, I will do the same for all the devices here. Okay, I will click here and click here. Okay, as we see here, the automatic mode used the two different types of cables. Used the cable that is called cross copper crossover, okay, this one, and used the other type of street cable, the copper street one. So why used two different types? Usually when we connect two two different types of devices, for example here, the PC as the end device and the switch, okay, we connect it with the straight one, okay, and if we connect two devices has the same type as router, two routers, okay, we have to use this one, which is copper crossover. So this means that wasn't I was not right here connecting these two different devices with the crossover. I should connect them with the straight one. So I need to remove this one and this one and connect them in the right way. This will not affect our lab, but okay, let's do it in correct way. I have to remove this one and this one. So how can I do it? I will go to this option here, okay, this X symbol, delete, and I will click on the cable and it's deleted. I will do the same for this cable here and it's deleted successfully. I will remove this symbol of delete, okay, clicking on ESC button of the keyboard. Okay, so let's connect them automatically. Again, okay, I can see that connected them with the straight one, okay. Okay, in this way we connected the two our network, okay, in correct way. As we see, the packet tracer shows us what interfaces he did, okay. Okay, now what we will do, the second step is configuring all the data terminal equipment devices as the PC, the routers, this router and this router and this PC. So we have to give all of them IPs and of course will be configured with mask. Let's first to be clear and easy configure. Let's add a label for each device. So I will add a label from this bottom here. It's called also please note, okay. I will click here and this is only a note, a simple note. It's not a configuration, it's not the setup of the IP, is only a note that I give for each device, okay, and I can add it in every in anywhere in any place. So I can write here OSPF lab, okay, as this way. So I will write here this PC, we will give it for example okay, 1.1.1.2 slash 40 24. Of course this is not a private IP, as we know this is a public IP, but I am not using the internet, I am doing a simulation. So I'm completely free to choose any IP I want, okay, from the usable IPs, okay. So of course we know that the switch doesn't take any IP, and okay, so I will go to do a label here, okay, configuring the IP for this interface, LAN interface of the router. I will give it as 1.1.1.1 as the gateway of this in the device, okay, will be as a mask 24. I will move it here, okay, and I will add another label here, giving the router one no, I'm sorry, 2.2.2.1 slash 30, the mask 30. Why mask 30? Mask for 24 I will explain in another separate video what does mean the mask, but as a simple explanation now, mask 24 means that I say to the to this LAN that I see to the packet tracer that this LAN can have IPs, okay, from 1.1.1.1, okay, and till, okay, 1.1.1.255 because mask 40 mask 24 means 255 IPs available, okay. um, of course we know that there are two IPs that can't be taken, the first and the last one, and I will explain this later, okay. Let's do it, write it in this way, okay. Okay, so let's continue our lab. So I will continue adding a label here for this interface, and I mean with this interface, I mean this part here. I will doing a zoom in to be okay. The interface of fast Ethernet 0 0 0. Okay, I will add a label, and I will say that this will be do to 2.2 slash 30, and such 30 means that I don't need over 4 IPs for this network here, okay. And I mean with the network between these two routers, okay. Okay, let's add this one, okay, add this interface. Let's add another one here to the other interface, okay. Here will be 3.3.3.2 slash 30, okay, mask 30, and let's configure here this IP, not configure, I'm sorry, I only adding a label of 3.3 4.3.1 as a gateway, okay. And let's then giving a label here for this WAN, okay. For this port of fast Ethernet 0/1, okay, will be 3. No, I'm sorry, 4.4.4.21 as the gateway of this one, and the last label we will add here of 4.4.4.2 slash 24 mask 24, okay. In this way we added all the labels for the devices. So this is the second step that we did. The following step will be configuring each router of these routers, okay. We will give them a name, but not these names. These are assemble labels, okay. These are not our labels, so we will call it as, for example, we can give them a name of cities, okay. We can call it Madrid, for example, and here we will be Barcelona, and this will be the service provider, our service provider that connects Madrid with the Barcelona. So will be service provider. So let's think about them as we have a company that has a branch on Madrid and the other branch on Barcelona. They need to connect them to connect together without the need of internet. So we are forming an private WAN, okay, and of course what the entity that connects between them will be the service provider, okay. There is no depth on this, okay. Now let's configure each router, giving it an IP and the DHCP and all these configuration, okay. So let's go to each router. For example, I will click on the Madrid one, okay, and I will go to the CLI configuration command line, okay. and I will here it's asking me that if I wanted to help me to configure the router, I will say no, because we will do all the steps together, step by step. I will press no, okay, and I press enter now. Okay, the first step is I need to give the Madrid a name instead of router. I will want to give it a name, so I will say enable. With enable, I will go to the second level of the commands. Okay, as we see here, the symbol is changed. Okay, from this symbol to this symbol here. I will go to the third level, that will be configure. Okay, terminal. I can press enter, but I will not, because I want to show you that I can do it as another way. I don't need to write all the words, all the command. I can only add as an abbreviation of conf and the space t, and I will press tab. The application will continue suggesting the name of the right command. I will press tab now. Okay, as we see, he says conf terminal. Of course, it's a configure, but I can write it in this way. I can press enter. As we see, we entered at the third level of the configuration. Here we can give to the router a name, and a name. This is not the name of the router. We added only a label here. I will give it a name as a configuration, as a software. So I will write here. We can say the host name. This is the command of giving the router a name. Okay, and I will write the name here. I will say Madrid, and I press enter. As we see, the router changed as a name, and here we have a Madrid name. Okay, let's give it as a password. Okay, to protect it. So I will say enable secret. Okay, and I will give it a password. I will write it in other way to show you the option of tab. I will say only NA, and for example, and I will say tab. He says to me, do you mean enable? Okay, I can delete it, but I really mean enable, so I will enable, for example. I will press enter. It completes for me. Okay, enable sec, and press tab. Okay, he says to me enable secret. Yes, of course. I will say as a password the word of Cisco. Okay, will be our default password. Okay, let's do it as Madrid. Okay, and press enter. Okay, let's see if our password is configured or not. We can go to the second. We need to go to the first level, but first we have to go to the second level. Okay, and we can do it as exit with the exit command. Exit. I will press enter. As we see, we returned at the second level, and to go to the level before, we can press Control Z. Okay, sorry, disable. Okay, disable, and we return to the first level. Okay, let's go again to the third level with first with the second level enable, and okay, look here, it asks me about the password. I will write it, but you know, as I used the command of enable secret, when I write it now, it will not be shown. It will not be shown when I write it, and this is the advantage of the command of enable secret, because we have another command, enable password. Instead of secret, we can set the password with the command of enable password. What is the difference? The difference is that with enable password, okay, the password is not encrypted, but with the command of enable secret, the password is encrypted. So I will write the password. First, I will write it as a wrong way, so I will write anything, 1, 2, 3, and I press enter. Okay, it asks me to the password. I will write anything to again. Okay, says to me bad secrets and returns to the first level, or returns at the beginning. So I would say enable, asks to about the password. I will write now the correct one, Madrid. As we see, goes now to the second level. It's say conf tab um, conf tab because didn't complete, because we have here, okay, more than one command that starts con. So the application doesn't know what command I want, because we have another command, it's called concatenate. Okay, so I need at least add another letter here to show to the applications that I need configure. Okay, so I will write tab here. Okay, now understands what I need. Okay, configure enter, configure terminal, and press enter. Okay, now we are at the configuration level. Let's now um, let's now configuring the IP and the IP for each interface. For this router, we have two interfaces, fast Ethernet 0, 0 and fast Ethernet 0, 1. Let's start with the fast 0 over 0. So we will start with the command here of interface 0, fast Ethernet 0 over 0. So we will take interface, but I will write inter, for example, tab, interface, fast Ethernet. I will not, of course, writing all the word, so I will say F, okay, and he will tab, fast Ethernet, 0 over 0, and press enter. So I says to the application, I need to configure now this port here, okay? Okay, so let's continue. Let's continue. Then I will say IP address 1.1.1.1, and I will write the mask. The mask here, it's written, okay, at the form of 255.255.255.0. So the translation of mask 24 is this mask here. I will press enter. Okay, so we configured, till now we configured this router successfully, changing his name from router to Madrid. We added a password as a Madrid, okay, and we gave to this port the IP of 1.1.1. Okay, let's do it for the second port. Okay, because we have to do it for each port. So we will go at the beginning of level 3, because here we are at the configuration zone of fast Ethernet 0 for 0. So we will say exit. Okay, now we return to the first form of the third level. Let's go and repeat the same thing of interface fast 0 over 0, and we can write it as this way, you know. Okay, look, I understand it, so I can write it as f 0 over 0. I'm sorry, we need to configure 0 over 1, not 0 over 0. So I will write exit again, and the interface 0 f 0 over 1. Okay, and I will write enter, IP add and address. Okay, 1 dot, sorry, do to 2.1, and as a slash, and the mask of 30 we can be write it as 255.255.255. Here we have only 4 IPs, so we will say that the number here is 256 minus 4, so will be 252, and press enter. Okay. So we configured the second port. We will do the same for these two IPs. So let's go to the service provider. I will say no. Okay, I will enable, and with enable I will go to the the third level with the conf t and press enter and say host name. We will call it service provider. We will set a password, enable passwords. Okay, let's call it let's set it service provider, a simple password, so only for learning. And we will configure the first port here, as we see, is fast 0/0, and we'll have this IP. So I will say for it IP address, okay, and I will say 2.2.2.2 and IP 255.255.255.252. Press enter. There is something wrong here. I'm sorry, I didn't specify what interface I am giving this IP to. So I will say interface and then fast 0/0, and then I will write this comment. Instead of writing it again, we can use the arrow of the keyboard to go to the past command that we write. So when I click on the up arrow, it says to me your root interface 0/0. I don't need it, so I will click again on the up arrow of the keyboard. It says to me that the command before this one is IP address 2. Okay, I say I need this, so I will press enter. We will do the same configuration for the second port, so we will write exit, sorry, exit, and for exit, look, I will say EX and I click tab, exit, okay, I will enter, okay, and I will say interface, first F0/1, and click OK, and I click IP address 3.3.3.2 255 255 255 252, and press enter. Okay, we configured it as a name, as a password, as the two interfaces. Okay, here. So I will go do the same for the last one. Okay, I will say here no, the same. I will do it faster. Okay, as we already learned it. Okay, enable, and I say conf t tab. I will say host name, and will be Barcelona, and enable secret tab. I'm sorry, I didn't enter the password. It will be Barcelona. Okay, and I will press enter. Okay, then the interfaces. The first one is F0/0, so I will say interface fast 0/0 and enter IP address. Okay, I will give it as 3.3.3.1 and as a mask 255 255 255.252, and I will exit to configure the last port that will be of F0/1 interface F0/1, and I will give it IP address 4/4.4.1 and 255.255.255.0. Okay, what I did, there is something wrong. Look here, I wrote 4.4.41. It's a wrong form, so I will click on the up arrow and I will go here, and okay, at that point. Okay, we did all the configuration successfully for these three routers, only adding an IP as and a mask, and configure a name and passwords. Okay, now we have to do a simple command for each router in order to activate it, because as we see here, these red flags, okay, this means that it's not enabled each router. So I will do as a simple command, okay, of it's called so first I will go to the third level, conf t. Okay, configure terminal. Okay, the command is no, it's called no shutdown. Okay, and I will write it as no shut. Okay, there is something wrong. Shut down. When we press enter, this these two red flags should be green, but of course, okay. Okay, there is an error because we are entering this command at the wrong level, as this will be as a second level, not as a second and the third level. So I will go to the second level. I press Ctrl Z, and I will say no shutdown. Okay, so no shutdown, and the same wrong is the same error we have here. I ask sorry because no shutdown, we do it at a level of the port, and if we need to do it at the level of the port, so I have to enter at the level of the port. So I will say configure, okay, conf terminal, okay, and I will go to the interface fast 0/0, for example, and I will say, okay, here, no shutdown. Look here as a Madrid router. If once I will click enter, okay, for this command, these two arrows will be green, okay, from red to green will be transformed. So I will press enter. Okay, as you see here we are green. This will be configured for some seconds and will turn to a green one. Let's do it for the other two routers. So here we are at the level of the interface. Okay, I'm sorry, but we have to do it at the second interface. Okay, so the same router, we will go to the interface of 0/1. I'm sorry, conf t. Okay, interface f0/1, and I will say no shutdown. Okay, okay, we do it. Because it's not red, because we have to do the same for this interface to have the same state to has the change at the same time for all of the two interfaces. We have to go here, and for the interface we'll exit here and conf t, okay, and interface, this will be fast 0/0, and I will say no shutdown. Okay, look, it became green because this already is not shut. It's took the command of no shutdown, but this was remaining, and we gave it now this command. So I will do the same for this interface. Okay, so we will say exit to go to the other interface in interface fast 0/1 and no shutdown. Okay, let's do the same for here. Once we will do it here, all of them will be green. Okay, as we see, conf t, okay, interface fast 0/1, and I will say no shutdown. Press enter. Okay, as we see here. I'm sorry, I already did the interface of fast f over 0/1. I have to do it for 0/0 here. So I will say exit, and do interface fast 0/0, no shutdown. Okay, so now we have all the same, all the interfaces are green, all are connected together. Okay, let's do a simple configuration for not real port, so an imaginary port. It's right way to configure the OSPF protocol. We need to configure an imaginary port for each router. How can we do it? We will click on the router and we'll go to the beginning of the level 3. Okay, and I will say okay the following one. So what is the command of interface? Something called loop back. Sorry, back. But we have to give it a number because we can create over up to 2 billion imaginary ports for each router, you know. So what is the exact number? I can say, I can write as question mark. Okay, and it says to me loop back. Okay, I did a space and the slash and the question mark. See, it says to me you can create up to this number of loopbacks and imaginary port. So I will call it 0, loopback 0. Okay. We create it. I will give it an IP. It will has to give take an IP. So I will call it 5.1.1.1 and as a mask. And this is not a real mask. I will explain it later why I write in this way and press enter. Okay, so this is the first step that we need to create the OSPF and to configure the OSPF protocol on our routers. Okay, so we have to introduce an imaginary port interface loopback, and we can see all the possible loopbacks that we can create, and here we have to give it an IP. Okay, and this mask here. Now let's complete the OSPF protocol on the first router. How can we do it? We will go to the third level and I will say router OS. It completes for me OSPF. I will press enter and it says incomplete command. Why? Let's suppose that we don't know why it's incomplete. Okay, so what should we do? We can do as a question mark. Here it says to me that the OSPF, the command of router OSPF should have an ID, process ID starts from 1 to this number here, 65,535. So why? What does it mean? OSPF, okay, means open source shortest path first. So since it's open source, of course we have here more than one model, okay, of the this protocol. For our lab, we will use the first model of number 1. So I will say 1. Press enter. Okay, another and the last protocol will say will be network. I'm sorry, network, and I will say 0.0.0.0, 255, and when I press enter, it says to me incomplete command. Let's ask to the application because it's incomplete. So I will do question mark. It says to me that you have to set an area. Okay, so I have to set an area ID. I have to write area, and when I press enter, it says it's again incomplete. Why it's incomplete? So I will say question mark, and it says to me that you have to give a number for this area from 0 to this number is to this number here. So I will give it 0, and I will explain later why what this means area. So I will call it area 0, and we configured it successfully. Let's do the same for the other two routers. Okay, so we will close this window and we'll open the window of the service provider. So in this way, we can, okay, we will go to the third level. I'm sorry, I didn't remember it. Okay, will be service provider. Perfect. Conf T. Okay. Let's configure then the OSPF protocol. So I will say router OSPF 1, and I will say then network 0 to 0 to 0 to 0, 255, 255, 255, 255, and area 0. Let's do the same for the third router. I will say enable, password will be Barcelona, conf T, router OSPF. I'm sorry, I write it. Incomplete because 1 will be. Let's move it here to be clear. Okay, I will say network 0 to 0 to 0 to 0, 255, 255, 255 to 255, and area of 0. Okay, we already configured the OSPF protocol on all the three routers. Okay, the last step before verifying the OSPF that we set up is to giving an IP for these two PCs. We can do it in two methods. The first one is dynamically with the routers, and the second with the protocol of DHCP, Dynamic Host Configuration Protocol, and the second one is a static way. Let's do it in this lab in a static way. So I will click on the PC, I will go to the desktop, and I will go to the IP configuration. I will say static, so this IP should be 1.1.1.2, and I will press enter. It says I will modify the subnet mask to 255, 255, 255.0. Default gateway will be 1.1.1.1, and DNS server, it's not important for us at this lab as we don't use the internet, so it's a private network, it's not a public network, so we can let it as this, but we will not have a problem if we set it as 8.8.8.8 as a DNS IP of Google. Let's do the same for the second PC, and to be sure that we don't need to change the DNS server, I will let this as 0 to 0 to 0 to 0. Let's give it an IP 4.4.4.2, and subnet mask will be 255, 255, 255.0, and the default gateway 4.4.4.1, because 4.4.4.1 should be the IP of the LAN interface of the router, this one here, okay? I will press enter, and I will exit. Now we have all is set up, all the devices are connected together, so this PC can communicate with this PC in easy way and indirect way first let's see the routing table of these routers to be sure that we set up the OSPF correctly. So when we enter here, and I will exit to go to the second level, I will say show IP route. Okay, let's focus here, and what we see here, we see that this is the IP route table. So this is a routing table that the Madrid router has. We see here C, and C stands for connected, so directly connected. So the router Madrid says that I have a directly connected interface, okay, of 1.0.0.0/24, but this is not the IP. Our IP is here, okay. 1.1.1.0 is directly connected as a fast Ethernet 0/0, and this is correct. It's here, 1.1.1.1 with the fast Ethernet f 0/0, and this should have another one directly connected to the 2.2.2.1 with the fast Ethernet of f01. It's here. 2.2.2.0 is directly connected with f0, because says 0, not 1, because here we have the name of the network. This, it's called the name of the red network as an IP, as the first IP. It's called the name of the network. It's not given to a device, so we can't use this IP for any device. We can't use it because it's called the name of the network. So this is the name of the network of the directly connected port at the left, at the WAN, and this is a network name 2.2.2.0, the second network name of the connected port at the WAN of f0/1. And it says that O, what does mean? Okay, O means OSPF. So it says, so I have other two networks through the OSPF protocol. The first one, it's 3.3.3.0, should be this one. And the second one is 4.4.4.0, should be this. Okay, let's see again. Okay. And it says that I have a directly connected port that we configured already of 5.1.1.1. Okay, so we are sure that all the routers see each other. So let's do it again here to see what the service provider router sees. We can say I show IP protocol. I'm sorry. Show show IP routes. Okay. Okay. We have the same here as OSPF. He says the Barcelona. I'm sorry, this is a Madrid one, and says that I have two directly connected ports, fast 0/0, fast 0/1, and has other two OSPF. This is my Barcelona, and this is the imaginary port of Madrid router. Okay, perfect. And the third will be the same. Let's try to ping to make a simple communication between this PC to the second one. I will go here and will click on the, from desktop, I will click on the command prompt. I will say ping. What is the IP of the okay, 4.4. So 4.4.4. I'm sorry, .2. And I press enter. The first one may be lost, and I will explain why. Okay, okay. Let's see here that all the other three pings are successfully received. Okay, from the destination PC. Why the first one is closed? This is because maybe the PC is starts to form a routing the ARPA protocol and other protocols inside the layers to be able to communicate and go through this network. Let's see another simulation. Okay. Um, with the same that we did, okay, but with a message here, simple message that we can write. First, we will go to the simulation mode, and I will write a message here, and I say that I need this message go to this PC, and I will click on start. What we will see the path of the PC. So let's do it. As we see, it moves from this PC to the switch and will then go to that router, and the router will route it to the other router of the service provider. Service provider has IP, has a protocol configured with all the IPs and the routers, so send it to Barcelona. Barcelona will send the message to the switch, and the switch will direct with the MAC and IP that have to the destination PC. The destination will respond to confirm that it received it. We here see as in progress, as this message will go to the PC again, the first PC. This will be successful. So service provider wrote it again. We can see here the steps. Okay, the message will return to the switch, and the message then go to as a response that he already received it. Successful. Okay. So in this way, I can confirm that we already did this lab in correct way. OSPF is one of the most important protocols in the networking in general, and at configuring the routers. I hope that this video was useful for you. I will explain. I'm sorry, I have to turn to real time. I'm sorry. Okay, so I will explain in more details what does mean the mask, what does mean these IPs, and each detail that need to be cleared. Okay, in other separate videos. Thanks for watching, and see you later.